Hi everyone, welcome back to my channel. So, if you are new to my channel, consider subscribing it. Okay, so in the before session, we have talked about like design methodology, what is top down design methodology and what is the bottom up design methodology and all. So, now from this session we'll be actually going into like full-fledged Verilog course, like what is the coding that we need in the Verilog and what is the type of coding that will be there in Verilog and all we'll be seeing from this session onwards. Okay, until now what you have learned is nothing but a general knowledge on like general view on all these things. Okay, so now basically what is the main important thing in Verilog is module. Okay, module representation. So what does this module mean? Module is nothing but it's just a basic building block. Okay, just like when you are building a house, how important is the brick for you? Is it or not? So group of bricks will be forming a wall and group of walls will be forming a room and group of rooms will be forming a house. Is it or not? In the same way, in this particular coding, like Verilog coding, module is very important. It's nothing but a basic building block. Just it is like a brick for the Verilog code. Okay, you can just estimate it like that. Okay, so what does this module consist of? What is the importance of this module? Basically, module is used in order to describe boundaries, inputs and outputs of the ports, and basically what is the code that you are going to write. So here if you see in this slide, see everything like whatever you want to write in the Verilog code, you should be writing it within the keyword module and end module. And module and end module is the keyword here. And in the previous classes I already told you that Verilog is case sensitive. So this is the syntax of the module and you should follow it in this way only. It should be in all lowercase, okay, module and end module. So whatever code that you want to write in the module, in the Verilog, you should be writing everything within this module and end module. If you want to write anything, it should be within the end module. If you enter anything after the end module, it will throw you an error. Okay, see, every Verilog program starts with keyword module and it ends with the keyword end module. So from the starting I'm saying that everything you want to write everything. So what is this everything? This everything consists of like ports. Ports is nothing but input, output, in-out. So basically you'll be learning it in the further sessions. Just in order to give you a basic idea, I'm telling that. Okay, basically input port, in-out port. Mostly you'll be using input and output. Okay, so whatever ports you want to declare, what is the logic that you want to write, everything should be within this module and end module. So let us see the syntax of this module. What is the module consists of? Module, and after the module you should be naming the module. Okay, module name, and then it is followed by the ports list. Okay, so nothing but input port, output ports, just like I have told you before. Every port that you want to declare, you will be declaring it within this syntax. Okay, and then your logic, and then comes the end module. Okay, so see, the name of the module should be given right after the module keyword. So as soon as you declare the keyword module, then you have to write the name. This module name can be anything you like you can write it in any way. Okay, there are also limitations for writing this module name. I'll be telling it in the further sessions, but it can be of any individual name of your interest. Okay, and then it should be followed by a ports list, optional list of ports. That means either input ports, output ports, whatever it is, you will be declaring it here, and it should be ending with a semicolon, right? And then whatever code that you want to write, like as I already told you, like for example, you are designing an adder, you are designing a multiplexer, so everything is having its individual logic and its individual code, right? So this individual logic will be entering into this implementation part. Okay, and then it will be ended. That means once your program logic is completed, then you will be writing the end module. Okay, so Here all variables declared, that means whatever variables that you are declaring here, like functions, tasks, you can write anything here. Okay, it should be within the module and end module keywords. And here like the default port width is only 1 bit. Okay, presently I'm not explaining this because basically you will be learning it once you enter into the once you know like ports list, what is ports list. Once you see the ports list video, then you will get clarity on this particular thing. Okay, so this is what generally the module and end module consists of. Nothing but it should be given module with module name and then ports list ending with the semicolon, and whatever logic that you want to write, you will be writing within the this thing, and then after completing your logic, you will be writing the end module. That's it. Okay, so in order to make you further understand this topic, I am just giving you a small example here. Like, let us see the full adder circuit example here. Okay, so this is the logic diagram for full adder, right? So ABC, sum, carry, you all know about it. So sum is nothing but A XOR B XOR C in. So see, A XOR B XOR C, and then carry is nothing but AB BC plus CA, right? So this is about the logic diagram, this is the truth table, and this is the expression of that particular thing. Okay, and then let us see the Verilog code, how we are going to write the Verilog code for it. Okay, so before explaining about the Verilog code here, first remember one thing here, just don't see the logic. Okay, don't bother about the logic that is placed here, because once you further enter into the further sessions of this Verilog, then you will know how to write the logic. Like, every logic will by here we are using various methods to write the logic, like various operators you will be using. Okay, like you can write in various kinds, you can write in either data flow, behavioral, or switch level or gate level. So based on our requirement, we'll be writing the logic. So presently don't bother about the logic in this particular example, just see the syntax, like how the syntax is doing here. That's it. Okay, don't bother about the logic or anything here, just remember the syntax. That's it. Okay, see here, module and end module. So as I already told you, module should be followed by a name, like any individual name. So since this is the full adder, I'm just naming it as full adder S. So why is this name very important? Okay, so basically, as I already told you, module is nothing but it's a basic building block. Okay, group of blocks, is it or not? Just like some strength of 20 or 30 students will be making a classroom, is it or not? So for example, if you are in a classroom with a strength of 20 to 30 members, and if you are not given some roll number or some name for you, how anyone could address you? Is it or not? If anyone want to address you, if anyone want to call you, you should have something like some name or else some roll number or anything. Is it or not? In the same way, as I already told you, you can write many number of modules. Module is nothing but building blocks, so you can write many number of modules in the code. And for example, if you want to use this particular module, for example, you are writing some 10 modules in your program, and you want to address the second module, so how we are going to address it, how we are going to call it, or how we are going to use it in other particular code, or else in the some other thing. So this is why basically every module should be given an individual name. Okay, and also when you are using this name for this module in your particular file, you can't use it in any other module in that particular logic. Okay, that means every name should be individual of its kind. Clear? So this is how module followed by module name, and then ports list. Ports list is nothing but, as I already told you, input and output ports. So what are the ports here? ABC are the input ports and sum and carry are the output ports, and then followed by end brace and semicolon. Clear? So see here, see module, module name, ports list. Similarly here module name, this is the ports list followed by n brace and semicolon, and then you will be writing the implementation of statements, nothing but logic, and then followed by n module. Okay, everything. So this is the art, we'll call it as a Verilog code, nothing but RTL code for the Verilog, like full adder, and this is the test bench code for it. Okay, just don't see about it. Okay, just remember that this is the RTL code and this is the test bench code. You will be learning it further when you enter into further sessions. You will be learning it, what is this RTL code and what is this test bench code and all. So as for now, just remember it that this is RTL and this is test bench code. Okay, so this is one way of writing the Verilog code, like module followed by module name and then ports list and then logic and module. There is also other way, like see here, module followed by module name and then ports list. You are not declaring which type of port it is, like you are not declaring the direction of the port, whether it is input or output in the module. Okay, like see here, module full adder. In the previous example, if you see here, within this brace only I have declared both input and output. Is it or not? Both directions, input and output, is nothing but direction of the port, which type of port is this. Okay, so here within the brace I am not declaring the direction, but I am just keeping it as A, B, C in sum and carry. Okay, and then closed with a semicolon, and then within the module I am declaring the directions, like input A comma B comma C in. That means these three are inputs and these two are outputs, and then logic and then end module. Okay, here one important thing that you need to remember is you shouldn't mix match these two things. Like you should, if you are going to write in this way, you should avoid giving these two things here. Did you get my point here? You should avoid these two. If you are going to give it inside the module, if you are going to declare the direction inside the module, then you should stop declaring within the module. Got my point here? You shouldn't mix match these two things. Like if you do the declaration of the ports in both within the module also inside the module also, then it will throw you an error. Got my point here? This is one style and this is one different style, another style you could say. Okay, but one important thing is you shouldn't mix match both things. Got my point here? This is about like Verilog module, like what is the module and what is the syntax of the module, what are the things that will be there within the module. Okay, and then next is module instantiation. So what does this module instantiation means? Basically, okay, before going into this, let me give you a small example for this. Okay, so for example, if you are having some study material, okay, if you want to distribute some study material in your classroom, okay, so the original study material will be only one. Is it or not? So this one study material, what you are going to do, this study material, whoever needs this, they will be taking the copy of that study material. Is it or not? Right? So basically the original study material is nothing but the original module. Okay, and whenever anyone wants to use that study material, what they should do, they should take the copy of that. In the same way, whenever you want to use this particular module in some part of your code or in some place in your code, then what you'll do, you will be taking the copy of that particular module and you will be using the remaining thing in your particular logic. Okay, so this is what called as instantiation. Instantiation means nothing but which is in that place, it is, we can call it as a copy of the original one. Okay, you could remember it just like that. Copy of the original is nothing but the module instantiation. That means is the active copy of the original module. So see, the process of creating object from a module, nothing but you are creating an object, like me creating a copy from the original module. That process is called module instantiation. And what are the copied products, like copied Xerox copies, those are called as instances. Okay, each instance, the copy that is taken by the student. For example, my I am having my original thing and you are taking all the copies from my original one. So now when it comes to your copy, you can do anything with that copy. You can write your name on that. Okay, when you are writing the name on that, you it will be becoming to you, it will be yours, not mine. Is it on mine? Mine is with me, mine module is with me, and yours is individual, that is independent and concurrently active copy, but that is copy of mine, but it may have its individual characteristics. Did you get my point here? Yes. A module instantiation, what does the module instantiation consist of? Module name followed by one or more instances. Okay, you will be seeing it with the example in the further session. Okay, an instantiation consists of, what does again the instantiation consists of? Instance name and connection list. Okay, we'll be seeing it here. See, for example, okay, I'll just explain it to you with an example so that it will be easy for you to understand. Okay, let us take an example of designing a full adder again. Okay, because I'm always revolving around full adder, half adder, multiplexes and all, because they are the mostly well-known topics for even everyone can understand. Like full, if you take the examples of full adder, half adder, multiplexer, decoder, so basically these are the mostly understood mostly well-known topics for all of you. So that is the reason why I'm taking the examples of this full adder, half adders and all. Okay, so let us see the full adder. So when it comes to full adder, we are designing it using two half adders. Okay, so now if you see the logic program here, Verilog code module and end module. See, whatever you want to write, you should be writing within module and end module, and then you are naming you are naming this module as half adder. This is the name of this module. Okay, and you already know the what does the half adder consist of? Two inputs, sum and carry. So two inputs, sum and carry are the outputs, and some logic inside this. Okay, so this is the block diagram and logic diagram, and this is the logic of the half adder. Now this is the half adder, but what do I want to design? I want to design a full adder. Full adder using two half adders, is it or not? Now, but I have written the code only for one half adder. If you see here, this is the code only for one half adder. Okay, now with this code I am going to design my full adder circuit. How? See here. See, this is my full adder logic code. So this is my full adder logic diagram. So module full adder, this is my full adder logic. So what does the full adder consist of? Basically, in before example you have already seen ABC inputs, sum and carry, output. Okay, now you are writing the, you are designing the logic. So from this, like if you see here, from this logic diagram you are going to write the code. Okay, so that is why basically wire. Okay, you'll be seeing this wire in the further classes. Don't worry about the logic and everything here. Now if you see the instantiation, this is called instantiation. What does the instantiation? As I already told you, instantiation is nothing but creating a copy of the original module, right? So what is the original one here? Half adder. This is my half adder module. Now what am I doing? I am using that half adder. If you see in the logic, see, module instantiation consists of name of the module. So name of the module, next followed by one or more instantiations, right? So here I am using two instantiations, like two copies. I am creating two copies with the same module, half adder HA0, HA1. Now again, what does the instantiation consist of? Instantiation consists of instantiation name. Okay, it can be again any individual name. So this instantiation name is HA0. This is the instantiation name. Here in this way, two instantiations. So two different names, HA0, HA1. Next, instantiation name and connection list. What is the connection list? Connection list is nothing but ports. So if you see here, the what is the connection list here? Since it is two half adders, so half adder basically consists of two inputs, two outputs, is it or not? So A, B are the inputs and S and C are the outputs. Okay, and now in the second half adder, C and S are the inputs. Okay, so here you will be seeing it here. Okay, scene, this is the scene, and what is it? S. What is the S here? C. S. Okay, these two are the inputs and sum and c1 are the outputs. Okay, so in this way, just like connecting, you are creating the active copy of that. In this way you will do the instantiation. So now what you're doing, you are just creating the copy for that particular module. Okay, now what I can use, in this way I can create any number of copies I want in my particular logic. So what is the concept here? Nothing but reusing. That's what I have told you in the starting. Verilog, why it is more reliable? Because it is used. In this way you can reuse your entire logic. See, instead of writing all these lines, you have just taken this particular name and you have next what you have did, when you are writing this name, that means this entire logic is placed here. Did you get my point? Yes, in this way the instantiation is useful. This is called as module instantiation. Okay, so this is all for today. In the next class I'll be further explaining about module instantiation and the next topics. Okay, that is all for today. Thank you.